Compute the probability that the binomial random variable for 5 and 0.6 gives us a value of 3. So remember what binomial random variables do. Okay, B and P counts the number of times where if we run an experiment n times in a row, we should get, or we count the number of times the outcome with probability P occurs. I would typically call that the probability of success, and we're counting the number of successes, but success can be defined based on whatever the question needs. Okay, so n is the number of trials, p is the probability of success. Okay, so here I can read this. We're doing something 5 times, and the outcome, the one of the two outcomes we're interested in, the one we want to count, happens 0.6. Okay, that's the probability for that. And we're interested in getting exactly 3 successes. Okay. Well, thanks to our work earlier, we know that we can calculate this using a formula. Specifically, write it down here off to the side. Okay, the probability that B and P is n p to the k, 1 minus p to the n minus k. So we've got our n, our p, our k, so we can just plug it into the formula. 5, choose 3, 0.6 to the 3, 1 minus 0.6 to the 5 minus 3, and the only thing I would do here is clean this up a little bit. You could, if you know 5 choose 3 is 10, put 10 in there. But I usually just say, well, 1 minus 0.6 is 0.4. We don't really need the brackets, do we? And then 5 minus 3 is 2. That's usually as far as I simplify an expression like this, unless I need to do something else with it. So there we go. We got our probability.